Hey guys, welcome back to the ICP Final Study Guide Unit 6 now, Chemical Reactions. Let's get started with question 1. It says, what are the signs that a chemical reaction has taken place? Right, there's two different types of reactions. There's physical reactions and there's chemical reactions. And while if you have a physical reaction, it does not change the identity of the substances involved, chemical reactions do. And some of the telltale signs of this is a color change that is unexpected. There's also the formation of gases, like bubbles, gas, and then we're just going to put bubbles. Like if you see bubbles forming, like if you put Alka-Seltzer in water, like the bubbles will rise up, something similar to that. There can be a change in smell or temperature. Another big one is if light is produced. Right? Of course, a physical change will not produce light. Chemical reactions probably, certain ones will, of course. And last but not least, the most important probably, a precipitate forms. And you might ask, what is a precipitate? And a precipitate is when you mix two liquids, like two aqueous solutions, and a solid forms. That is a precipitate. Alright, moving on to question 2. Alright. Chemical equations use coefficients to make sure the reaction follows the law of conservation of mass. The mass of the reactants will always be equal to the mass of the products, right? And that means that whatever we have on the left side of the reaction, we will have equal amounts in the right hand side, because you can't create or destroy matter. So question 3 here says, label the parts of an equation: the reactants, products, coefficients, and the yield/react. And so let's go ahead and highlight the yield/react. That's going to be this arrow here. That just means yield and react. So if we do reactants, what we all you have to do to memorize this is think about where the substances are. Reactants react to form or produce products. These are our reactants, right? Everything before this arrow, left of it, is the reactants, and these will be our products. So that's good. And coefficients are the numbers in front. So these numbers in front, right? And the ones without numbers, there's an invisible 1 there. We have to remember that. These are our coefficients. Alright. 4 says, a reaction between two atoms that creates new material is a blank reaction. Well, that's going to be a synthesis reaction. Let's write that a little better. Alright. Synthesis reactions, right? If you look at the news and say, a new pharmaceutical company has synthesized a new drug for the market, right? Synthesis is a reaction between two atoms creating one new thing. Next, question 5. A reaction where one compound breaks down into its components is going to be a decomposition reaction. Right? It decomposes into its respective components. Next up, 6 says, a reaction between an atom and a molecule that causes one ion, that's a spelling error, to switch places with another, right? One ion is going to be single displacement, right? Single displacement. And you can also say single replacement. right? This is basically the same thing. So equals replacement. Interchangeable. You can say single replacement or single displacement. It does not matter. 7 says a reaction between two compounds that causes two ions to switch place, right? If 6 was talking about one ion, this is talking about two ions, right? This is going to be a double replacement. So double displacement is how I like to say it. Double displacement reaction. But you can also say replacement. And last but not least, a reaction where carbon dioxide and water are produced from oxygen and a hydrocarbon fuel is a combustion reaction. Right? Combustion. Right? From a hydrocarbon fuel, you're making water and carbon dioxide. And of course, you need oxygen in the reactant side. And this, to be exact, would be complete combustion. But of course, you do not need to know that far, since this is just basic ICP. Let's take a look at 9a. Balance and identify the types of reaction below. Right, we have C3H8, O2, CO2, and H2O. Well, we talked about this, right? We have hydrocarbon fuel, propane, and then we have our oxygen going in, which produces carbon dioxide and water, which is going to be our complete combustion reaction. Let's balance. The way to balance these is very simple. You just have to remember to take it one step by one. I always start with the carbons and balance those, then the hydrogens, then the oxygens, since there's more than one oxygen in the compounds. Alright, so how many carbons are there on the left-hand side of the arrow? We have 3. On the right-hand side, we have 1, so a 3 has to go in front of the CO2. That changes the amount of oxygen as well, but we'll deal with that later. We have 8 hydrogens on the left-hand side of the arrow. We have 2 hydrogens on the right-hand side. So if we need to go from 2 to 8, we have to multiply this H2O by 4. That balances our carbons and hydrogens, so we're all set for that. Now we have to look at oxygen. We have 3 times 2, which is 6 oxygens on this side. And we have 4 times 1, there's an invisible 1 there, which means we have 4 more oxygens. That's a total of 10 oxygens here. 10 oxygens, right? So then, how many oxygens are here? Well, we have 10 individual oxygens. Not O2, just O. So dividing that by 2, since it's O2, we get 5 for this, right? 5 times 2 is 10 individual O's, which cancel these respective O's. And of course, since we handled all our C's and H's earlier on, this is a 1. But you do not have to put that 1 there. You can just leave it blank, and it's understood that it's a 1. Next up, let's take a look at the 9b. So we have one ion here and another ion there. Another ion here and another ion there. And these ions switch places to form these respective substances. This is a classic example of double displacement. Double displacement. Right, 2 ions switch places with their respective opposing cation and anions. Let's take a look at balancing these. So I just always just go left to right, right? We all read left to right, so it's easiest to balance left to right most of the time. So if we take a look at Al, right, we have 2 Al molecules here, but on the right-hand side of the arrow, right arrow, we have 1 Al. So we need a 2 in front of that to cancel the Als. Next, taking a look at SO3. If it's in the parentheses, it's good practice to just leave it in the parentheses. Don't distribute this out and, you know, that too much. No. Just keep it in the parentheses and you'll be all set. So we have 3 SO3s on the left-hand side, but we only have 1 SO3 on the right. So 3 has to go there in front. Next up, we have NA. We have one of those on the left-hand side. But we have 3 times 2, right? There's a 2 there. 3 times 2. We have 6 NAs here. So there needs to be a 6 there. And last but not least, our OH is also impacted by that. 6 times 1 will give you 6, right? Of course. And 2 times 3 also gives you 6. So this equation is now balanced. Next, 9C. This is kind of similar to B, but this time only one ion will take the spot of the Al, right? And so now it's replaced. So this is an example of single displacement. Single displacement. All right, and you know, it's just the same way to balance these. It gets repetitive over you know, if you practice a lot, but I mean, it's just you once you realize and understand how to do this stuff, it's like riding a bicycle, right? You never forget as long as you're doing chemistry. So starting off with the first, right, we have Al2. We have 2 Al molecules on the left hand side of the arrow. We only have 1 Al on the right hand side, so 2 needs to go in front of that. Next, oxygen. We have 3 on the left-hand side of the arrow and 4 on the right-hand side of the arrow, right? So what's a common multiple that these all fall underneath, right? That's what you have to ask. I usually just multiply them together and divide them out once if you have like a common denominator you can find, but I'll show you how that's done. So we have 3 there and 4 here. So if you multiply this by 3 and this by 4, you're going to get 4 times 3 is 12, 3 times 4 is also 12, and your oxygens will be balanced. But that means that you have to adjust this amount of aluminum because we just fixed the ratio of that to 4. So 4 times 2 is 8. So now this number needs to be an 8. Last but not least, we can calculate our iron by 3 times 3, right, which is of course 9, and that is going to be our most simplest, most balanced coefficients for this reaction. So I feel like the key concept to this one is realizing that you have to find the multiples of 3 and 4 where they each are a common factor, right? So the easiest way to do this is just multiply the two numbers together. If you can't, you know, it's not nice, neat numbers, right? If it was a 2 or a 4, you can just multiply this by 2. But of course, you know, life sucks, and you don't get easy numbers always. So just multiply these small numbers, the subscripts as we call them, and you'll usually get big numbers. But if you have common multiples or common denominators, you can always just cut them off and make them most simple. But in this case, 9 and 3 are odd numbers, so we will not be able to simplify it with the even 4s and 8s. So this is going to be our answer. Next up, we have D, KClO3 reaction, right? This is kind of fun. These are going to be easy to identify once you memorize the 5. Of course, you got a note card, so write them down if you don't know. But let's take a look at this one. So we have one substance that breaks apart into 2 substances. A classic demonstration of a decomposition reaction. Right, decomposition. So I just start with the K's. We have 1K on the left-hand side of the arrow and 1K on the right-hand side of the arrow. So these are all set. Don't worry about them. Next, we have Cl. Cl's are all set. We have 1 on each side. This is another example of multiplying with the commons, right? We have 3 oxygens on the left-hand side and only 2 on the right-hand side. So if we multiply 3 by 2, which is this number right here, and this 2 by the number 3 here, our oxygens will cancel out. We have 2 times 3 is 6 oxygens here, and 3 times 2 is 6 oxygens here. But that just changes the ratio of the KCl, and that's what this here is for. So we just multiply these out, right? 1, there's an invisible 1 after each one of these, remember. 2 times 1 is 2. So we have 2 Ks. And there's also an invisible 1 there, so we have 2 Cl's, right? So we just put a 2 there. Erase all that real quick. Just put a 2 there. That's 2 K's, 2 Cl's, and then we're balanced. Last but not least, let's take a look at 9E. This is, of course, a classic example of synthesis, right? Synthesis. Because we have 2 separate compounds that merge into one. And of course, this is, we just start off with the leftmost element, N2. We have one N here, one N here. N's are balanced. Let's take a look at the hydrogens first, since there's an oxygen here and an oxygen here. 2 hydrogens on the left-hand side, 4 hydrogens on the right-hand side. This number has to be a 2 in front to get 2 times 2. That makes it 4 hydrogens. And so that changes the number of oxygens, right? We have 1 oxygen here, 2 oxygens here now, for a total of 3 oxygens on the left-hand side of the reaction. We also have 3 oxygens on the right-hand side of the reaction. And so as long as we verify that all the elements are there, this equation is balanced. 2 nitrogens here, 2 nitrogens there, 4 hydrogens here, 4 hydrogens here, and 2 plus 1 oxygen here. And this is a balanced chemical reaction, right? Simple one to end that off with. And I believe there's one more question. One more question. There it is. Yeah, this one. Question 10. What are the 2 reactants in a combustion reaction? Right, we talked about combustion, and the only combustion you're going to be asked about is complete combustion. And the 2 reactants, remember, reactants are the stuff left of the arrow, left of yield arrow, I'll say. Right? The 2 reactants is going to be a hydrocarbon. Right, 1. Hydrocarbon. And that's just basically saying it's an element made only of carbons and hydrogens, right? And X, here, I'll just write this out, where X and Y are numbers, right? So, good one is methane, right? CH4, ethane, propane, butane, pentane, that stuff, right? Just carbons and hydrogens in the chemical, or like the substance, that is a hydrocarbon. And the next one, of course, is oxygen, and that's just O2. So those are our 2 reactants, and our 2 products, of course, is going to be carbon dioxide, that's CO2, and water, H2O. But the question only asks for the reactants, so this here will be your final answer. And that wraps it up for Unit 6, and we'll see you back in Unit 7 for some fun stoichiometry. Thanks.